Now let's skip to the agenda, just a short one. I'll give you an introduction, some background and history as to my diagnostics, and then Fabi here will take you through the nitty details of the architecture, the ins and outs of how this thing works. So we'll start off easy. Obviously, Cisco has customers. These customers have network devices. And from time to time, as we know, all know, things might go occasionally wrong. And that's when the customer, if he needs help to solve this, opens a TAC case. A TAC engineer of the TAC CSE community. We have today approximately 3,500 TAC engineers accepting customer cases. They troubleshoot the issue and they get back to the customer with a solution. We handle roughly 1.8 million service requests per year, the whole TAC community. As you can imagine, that results in a huge amount of intellectual capital, a huge amount of customer data or insights on troubleshooting customer issues. The problem is that while the engineer troubleshoots an issue, that intellectual capital remains within the mind of that specific engineer. So to tackle that, we created an app store where CSEs could script their IC, and that way the knowledge of one single engineer gets spread to the whole CSE community. At first, it was done manually. Engineers had to go in the App Store, select the script, select the attachment of the service request, run the script against the attachment, and get back the results. But shortly after, we discovered a way to automate this. So the automated diagnostic engine automatically scans the attachments of the service requests and runs the appropriate scripts against those service requests and sends back the results in the service request.
So when I open a case with you, I always get this, send me show tech, and you get that long, meaningless printout. And are you telling me that now you're running a zillion of custom written scripts on that printout, and one of them might say, I've seen this before?
Yes. Exactly. Okay. That's the concept in a nutshell, exactly.
Nice.
So it automatically goes into the service requests of the TAC engineer. And this is basically how it looks. So he gets a breakdown per category and can zoom in on the warnings based on the severity level. Now, what we discovered is that while running the engine automatically, we on average get like 12.4 alerts per run. But it doesn't make sense to bombard the customer with all those alerts because they might or might not be relevant to the reason why he opened the SR. But what if there was a way that we could still get the alerts back to the customer, but without the framework of a service request? And that's where my diagnostics comes into play. Before we started to develop, we did our homework and created a lean canvas. This is taken from the lean startup methodology, which we applied while developing the concept and the actual bridge itself. And we started off with defining the problem. So there's a lack of TAC level knowledge within the customer's environment. There's also the problem of getting scalable data processing automated. And then thirdly, there's a high cost associated to maintenance tools. Maintenance tools are quite expensive. Before we started to build, we did our homework yet again and did some customer problem solution interviews with some customers. And from that, there were three main things they wanted to see in the solution that we were thinking of. Firstly, the solution had to be integrated in the workflow, meaning that they didn't want yet another dashboard to consult. I can see that you relate to that, right? Then the collection, the processing, the transferring of the data to Cisco should be done automatically. Not like you mentioned before, the engineer asks for a show tech, you have to dig in the show tech and see what it is the engineer needs. So customers want that to be done automatically without any manual intervention. Okay. And then thirdly, Customers do not want alert duplication. They don't want to get the same alert over and over again through different channels. Just one channel, one alert, that's it. And then to add to that, the My Diagnostics fits perfectly into the Connected TAC strategy, which baseline it is that no customer should be hit by any issue that Cisco already knows of. And that's the perfect way to work towards that strategy. What makes it unique is that we have the knowledge of 3,000 plus engineers who handle real customer problems. They have the key to solve those problems. They handle 1.8 million SRs per year, so it's actual SRs or knowledge from actual CSEs working on real problems that we would be able to bring to the customer.
Just one quick question. It is not one tag, actually there are multiple tags, yeah? Following all the different tags the same approach? Or is this specified for, I don't know, route switching tag or so?
No, it's a whole tag, it's adoption. I mean, the key here was really like this internal app store to get the community engaged. And there we were internally, we got the Pioneer Award, so it's up to Chuck. This is the thing where we go.
So it's a universal approach, yes. Yeah, okay.
And it's kind of embedded in the engineer's workflow by now to consider to script what it is they found that solved the issue. Looking at the customer segments, we touched on that earlier. It doesn't necessarily mean because the customer opened an SR that he's interested in those additional alerts that we might find. So we discovered quickly that the network operator is the guy we're after. He's the one who's responsible to keep the network up 24/7 without preferably any outages and to keep it running as optimal as possible. So you can see that these guys really have a benefit in receiving proactive alerts on issues that might occur on their network and that might cause an outage. So we have that identified that the network operator is the guy to go for. If we think of personas, what would a network operator look like? It might be an employee of an end customer who's responsible for the operations of the network. It might be a managed services partner. And it might as well be a Cisco network consulting engineer from our AS colleagues. I'm very happy to say that this is not just slideware. We have customers actually using My Diagnostics. First of all, there's Cisco IT. Actually, the Cisco Live network is powered by My Diagnostics. In the spirit of eat your own dog food, we're not afraid of testing what we developed. And simultaneously, we have a market trial, the Connected TAC market trial that is going on, and in which we have a wide variety of around 20 customers who are actually testing My Diagnostics. When I say a wide variety, I literally mean there are governance bodies part of the testing. Some commercial customer, supermarket is testing it, as well as bank institutions. So we have a wide variety covered. So that was it on the background. So you get an idea of where we're coming from. And now Fabi will take you to the nitty details of how we designed the whole thing.
As you saw, the way bring that automated diagnostic engine to customer. So let's start again a bit. So we do have network. We do have network operators. I mean, that network operator is a very old term, but basically the guys taking care for the IT infrastructure. And we do have cases coming in, getting digitized. And the very first thing we were doing is we mirrored the internal machine with a light IC governance, just to make sure that typical engineer April 1st jokes are not appearing straight to customer. The whole thing is firewalled. So with an API in front. And that's basically like something you don't see from outside, from a customer point of view. It's the whole machine is built already at early days with Docker. So basically, if a scan happens for customer, we spin off a little VM kind of, analyze it, wipe it out afterwards, and give the results back. So it's not like something where we take show tags and host it there in Cisco. Depending on country regulation, you can imagine how important it is. I'm Swiss, you can imagine what it means.
Question on the diagnostic engine, particularly on the tests. Do the tech engineers write the tests themselves, or is it just, oh, I found this, could someone please code that?
Normally the engineers, it depends. Engineers are writing, I mean, that's kind of like the power tool for engineers. They prefer to write the test by themselves because they see the impact afterwards, and it's much cooler to script something than writing a Word document. So we can imagine that. And we do have coaches guiding, and we do have also simplification for simple pattern matching in areas. You can even do it without a lot of coding knowledge. But you have a community over 1,000 engineers which are really able to write those things, which is also a huge motivation. Let's say on customer side, as mentioned, we don't provide you something, a new portal or just another portal. On customers, and we assume they already have their NMS system or they capture their device list in their CMDB. They may already have their internal ticketing system. And basically what we are providing is the My Diagnostic bridge, which is just connecting the things together. So you can choose the device list from source of truth as customer, wherever it is. You can choose how the information gets collected. And then it handles the entire back and forth to run the diagnostic in the appropriate way. And at the end, from a UI point of view, you can access it directly for configuration and for testing or whatever. And you have a UI out of the box where you can start. We come to that point afterwards. So if you're looking here, also that we are not just sending alerts to customers. We have a very tight feedback loop which goes back, so it's measured, because it only brings, from our point of view, it only brings value to customer if we are identifying problems and customer is taking action. Because if we are just spreading around those alerts, it's not going to happen.
So, but the whole thing is totally customer driven. So the customer has to collect his printouts, whatever, push them over to you through this bridge, gets the results, and then implements the recommendations or not.
It can go to full automation. I mean, like collection and so on, even with remediation. But as you can imagine, there needs to be kind of like customer, Cisco needs to come together. So most customers at the beginning are like this, and then after a certain while, it goes closer and closer. So you can really go from doing nothing, even controlling every single show command which is getting exchanged, up to just sitting there and watching how the network gets fixed.
And the next question, as you are getting those show commands, do you keep them for analysis so that maybe a week later you discover something else that could be applicable to my network? Would you tell me, hey, we've seen your show commands last week, and oh, by the way, you might be hit by this one as well?
Yeah, it's a very good point. So there are two options. The way we are doing right now, because right now it's more like, oh, what Cisco's doing with my data, we are wiping it out. But you have a scheduler here. So the scheduler can scan it once per day. We even have now a mechanism, it's not yet in production, but we have a mechanism that if there is a new important IC that the diagnostic bridge gets informed and so says, oh, there is something really urgent, we need to scan it right now. And we basically leave it up to customer how and when it gets scanned, because depending on customer, they don't want to collect show command during operational hours or whatever.
But we don't keep the show text to
Yeah.
rerun afterwards.
Yeah.
That's important too. Yeah.
Yes. There is an enhanced service where you really can bring the data and then you get tech engineers assigned. We also do that in the market trial. But in that area, it's more like going back in the data. But normally, we just collect where we have ICs for, so we are not gathering this amount of data.
Sorry, did you think about applying any like AI to this?
Yes, we do. I will come back to that later. Yeah. So the bridge. No, automated software recommendation. I will come back to that later, which hooks in and also provides there the information. The bridge itself is just a piece of universal software, like a Swiss Army knife, full of APIs around. So basically everything you see now afterwards, you can do via API. So customers which are preferring to control it and integrate it, they can do it by themselves. So like, I mean, I'm sure you're familiar with Swagger or whatever. So all the APIs are there. You can trigger the scan from external. You can add your device lists and so on. I mean, we could browse through it, but most likely not so interesting for you right now. So then the next part where I would like go to be deeper is like on the device list. So how do we get the device list? What we are having is, of course, to start lab-wise also, you can do your manual device list import. But we also have a generic API where you can synchronize it. For example, NetBrain, they did an integration with their software. WhatsApp Gold, for there we have a plugin out of the box as well for ServiceNow and so on. And then, of course, for the Cisco palette of devices, you can also use them. In order to collect the device data, so if you want to go for automation, yes, there is a built-in SSH collector where you can have the credential as external, so it just tells the bridge how to collect it. And then also API, where others can integrate if they are existing collector. Again, NetBrain was doing here. Or using Cisco collector. And optionally, we also have Telnet because you won't believe it. We had to add it afterwards because there are customers which are having still devices only supporting Telnet, and they still want to at least know that those devices are existing. Now, don't need to clean. On the part here, what I'm showing here is now a quick demo on that access on the API. So what I'm showing you here is, and it's pre-recorded, so I'm not cheating, but I mask out customer data because the stuff is unfortunately production, or luckily production. So yeah, so basically, if you can access it by a browser, and then you get the overview where the alerts are, you have the device list. And if you just check a specific device which is added, you kind of like see all those alerts there. Those are just informational, that's why they haven't been solved at all. Now what I'm doing in that demo is I'm intentionally making something bad on that ASA, and then I'm doing a manual scan. So what I'm doing here on the ASA, I'm adding this command which is generating two problems. And sure, you guys already remember that, what's going to happen. And then basically doing a manual scan. So I just go there and say scan this device. And then from there, everything happens automatically. So it's going back to the backend. It says, I need for this box these and these commands, upload it, and then you see issues has been found. There is an additional warning there where we are now just looking at, and then you see that login configure flash has been catched there. This is just like a simple example how that works. And all that information you get out from the APIs, or if you are doing a integration into an existing ITMS system, this information is sent into that ITMS system. I will show you afterwards an integration with ServiceNow as well. So here we also have recommendations, remediation recommendations. I mean, that's an easy one. But what you can do is, I mean, you can approve that recommendation, and then the bridge is going to apply it. And then at a certain moment, you can say, for this specific problem, I'm going to automate the remediation. So you can even go a step further. See, scans again, problem is gone, everyone is happy, and then you get the report on it.
So it's not that the bridge would pre-collect all the data from the device and send it over. It's executing commands on demand as requested by the
By the backend, yes. Mostly. For example, an ASA, very simple. It's a show tag. Is in it there. We can run 8,000 signatures against it. That's already great. iOS XR, if you collect the show tag, it will open a tag case because the box is crashing and you need to upload 5 gigs. I'm joking. But keep in mind, often we troubleshoot like a tech engineer. We take a command, and based on the command, we may request something else. Like a simple example, if there are different line cards in it, I'm going to take different commands. And there is logic behind. And we only take those commands we need where we have intellectual capital for, because we have enough show tags in our tag database. We don't need them.
So one question, how is it going with the controller-based approaches? So I have now imagined ACI, yeah? Or if you go for the DNA story, or even with Firepower FMC, where you have a centralized controller that is storing the let's say, configuration. Do you have an integration to these as well?
Yeah, we are working on that, like Firepower I just mentioned, just fully in testing right now. And that goes more in the direction where devices are already almost connected to Cisco, which makes the life a bit easier. But from a functionality point of view, we can do exactly the same then. Okay,
so you are not depending on logging into the device, do some, let's say, command on the CLI. You can also do the API way, yeah?
Correct. Yeah. And yeah, it's just a matter on the plugin and file upload, depending on how it is on API one. And that's kind of like, I mean, DNA, we don't have yet millions of tag cases with DNA yet. So we also prioritizing the approach, how we are doing it. I mean, a lot of things are new there, but the whole system is completely independent from them. Of course, the way we started initially, it was like typical CLI thing, but in the meanwhile, the whole system emerged to be a kind of like CLI independent thing. Also on the recommendations, yeah.
Have no bugs, or there are not so many customers?
Good. So from the possibility, you see, I just want to highlight one small thing. So if you're having an alert, this is not just an event, like not just like a Syslog message, because there are always real problems behind. So what you actually can do is like, and this is also like for the workflow integration. I mean, it's possible to say, okay, put it work in progress, because someone is now working on it, that if you have 20 guys, that not all are going back to it. You can ignore events, because depending on the setup, maybe something is not relevant. And because those is a real result database behind, where each is having special state, you can even do bulk ignore, for example. You can say, okay, this is not relevant in this network segment or whatever. So that's all done, and that's what we basically learned with customers, that we cannot just dump data, because at the end we want to make sure it gets either in a clear state, so we also know what customers are doing based on that.
Sorry, I have to ask again. The log data that you showed here, how is this getting to your device? Is it a syslog, or will you pull the logs on the CLI, or how do you get the logging information?
Example here with Nexus, and the specific example before, there I was just directly accessing via SSH plugin. In other example, like with, for example, with NetBrain, they bring the data in their way where they have it stored or whatever, depending on really the way how customer is collecting the information.
So you can work with configuration data and with log data, with both, yeah?
Yes. To be very clear, and it's very important, I want to just say it here because you are asking, we are not going to replace existing monitoring system. I mean, this is based on tag data, so we are not, this is not becoming a Splunk or something like that. We are not going to replace the network operators. It's really like the goal from Connected TAC. Issues we know, customers should know and should be able to fix them proactively. So that's like very, very important. And yeah.
Looking at that previous slide, got, you're probably already doing this, just didn't mention it. Do you have something like Syslog Analyzer where I could just feed you all these weird syslog messages that I'm getting but I never understood, and you would tell me how to fix them?
We do have a Syslog module, and it's doing almost what you wish for. With the Syslog itself, we are right now in the process on making sure that, because it stays in the logs, that we can accommodate that. Because there are certain Syslogs you want to ignore, and if you ignore it, you just want to ignore forever, versus you just want to acknowledge it, because you don't want to delete it. But yeah, that's something which is growing, and there we are working towards to that weird thing to make it much more clear there.
And so just that I understand the workflow, so I don't know, you have Kernel Panic 101, it's just I'm making this up, yeah? And you have recognized in the TAC every time a customer was before enabling this and this feature, this was resolving in the Kernel Panic. Then you have this intelligence, you can feed it to your engine, and in the next customer that opens a TAC case, you actually know already we have to search for these log entries, and then we know this will happen, yeah? That's
kind of like how the machine internally works on the TAC cases. With the diagnostic bridge, we make that available for the customer, so they can proactively run it every day and against the entire network. So like not just for one device, so they add their device list and make the full-blown. I maybe can quickly show you this ServiceNow one.
If the TAC discovers new defects, this will be automatically then feeded to here, and if you are aware of it and some TAC engineer put the info into the system, I get alarms about it, yeah? Okay.
Next crazy one. You guys have probably figured out that running features A, B, C, and D on the same box usually results in a crash. Is there any way that you could tell me that if I'm running features A, B, and C, better don't turn on D?
Yeah, well, probably if you have a signature for that, you would need kind of like fake the configuration and send it, and it will tell you. But it's a very good point.
No, but that would be reactive yet again. I already made the mess, and you're telling me why I made the mess. I would like it to be proactive.
So that is something like VMware prevents you from doing on the distributed switching if you configure something that will completely disconnect you from anything, like, no, you shouldn't be doing this, sort of thing.
I want to reach out to you afterwards. It's a cool idea. I like it. So, I mean, out of the box, couple of reports I'm just showing two. It's like the health against the total checks. So the health increase, and also something customers really like is like the work they've did. So all the work we've done. It's a bit the boring one is for testing, but we just ignore. But basically you see which issues has been solved. And that's really great. At the end of the month you can show, hey, this was my proactive work I was doing. Now to setup, I mean, you can cluster the bridge. So you can have it in a separate one, like small customers managed by one partner or whatever. You also do that, so you see all the bridges there, and you get an overview, and you can reach out. That's like all there out of the box. So it's pretty. I think a small Swiss Army knife. It's not going to be the full-blown FA-18 fighter plane, but it really helps. It really helps you where you can go fast and identify the nasty bad things. So the part here, workflow integration, that was really great. We were able to make a super collaboration with ServiceNow. Not that this is only. I mean, you can have JetOps. You can do it on Cisco. You can have a generic one to integrate or whatever. But the interesting part with ServiceNow, we had one large customer with several end customers where we were able to pilot this, and we ended up in making a full-blown workflow integration. So I'm not sure how we are with the time, but basically what happens here is that this goes in the area, what you mentioned, Ivan, that you just sit there and you do nothing and just watch how the tech is going to solve it. So from ServiceNow, you get the device list, which is typically source of truth from the CMDB. And then what the bridge is doing based on schedule, it's scanning it and infuses the alerts into the events, like from ServiceNow. They go through the entire, they bubble up through the entire stack. So you do have the events there, they bubble up in the entire stack, and there you can do the entire change management afterwards. So like small customer, large customer, that works. So that's also the possibility where then we can use the workflows out of ServiceNow. And the nice thing there is that allows you to automate things. So like if a network operator is doing certain automatization for a specific alert, it gets first reviewed and then they can automate it from ServiceNow. Because from a tech point of view, it's very difficult to know, can I do the change now or not? But if it's in the customer workflow, we can just offer and they do it. The nice thing here is with that integration, if a change has been done, it's rescanning to validate the change and is afterwards automatically closing the problem in ServiceNow. So that's kind of like where the whole workflow is there. And where we were able to build an app in ServiceNow. So all the nice UIs, all the nice things, a customer can just install it and do it with My Diagnostics. It's one use case, but a quite powerful one in an operation work to take the tech knowledge there. Again, just to highlight, we have a huge system, there is a network, and we just are a little bit of best of breed standing in it. We are not replacing the other systems because tech is not going to do it. Two others, I promised you. I'm not tracking, no problem. Because we have the collection, we can do a data collection request if there is a service request open. So they can send it, it goes and asks approval. From it collects it and attaches it to the service request. We can save a lot of time there. And then also the other part in regards of AI, because we do have knowledge about the tech cases, we do have all the problems from the automated diagnostic, we do have the feedback from customers, we can now make a very appropriate AI software recommendation. We were running a pilot, engineers against machine, and the machine was 100% match with the engineer. Where we were really proud. I was totally not a believer that this is going to work as a former tech engineer, but machine was providing same, but faster. So that's, I would say, little part.
Feedback is like the engineer saying, well, the suggestion you gave me didn't work, or they did work. So the algorithm proves the future solutions for the same problem.
Yes, correct. Yeah. So, wrapping up and having the experts in the room. I mean, you've asked about, what is if we are having connected devices already to Cisco versus staying safe in Swiss bank, Switzerland, or even having the automated diagnostic engine on-prem. I mean, that's going to be something interesting to know from all the customers in which direction we need to head. And with all of that,
I can tell you what the Swiss banks will tell you.
And just a very short message on where you can find out more. If you run a search on Connected TAC on Cisco.com, you'll end up at the page where you can find the details for potential customers who would be interested in getting on board and starting to test. And there's the mailer at the bottom of the page where you can reach out if you have specific questions or inputs.